We have a boat moving with initial velocity 30 meters per second, and after 100 meters we have a marker, so it's somewhere here. Let's say this distance, let's call it x1, 100 meters, and this boat decelerates with 3.5 acceleration. So basically acceleration, magnitude of acceleration equal to 3.5 meter per second. Negative means to the left direction of the acceleration is opposite to the initial velocity. That's why we have negative sign. So question is, how long does it take the boat to reach the buoy, to reach this point? Let's call it point 2. This is a point 1. First of all, we need to answer to this question: will it reach this point? This is very important, I think. So basically, let me find if it keeps decelerating with this acceleration, then how many meters it will cover and stop, how many meters it will travel and before stopping. So basically, let's say final velocity square equal to initial velocity square minus 2ax. We know that this boat is moving with constant deceleration, constant acceleration, and after how many meters it will stop. So final velocity will be 0, initial velocity is 30 square, 2 times magnitude of acceleration is 3.5 times x2. So x2 will be equal to 30 square, which is 900 over 2 over 3.5, equal to 128.5 meters approximately. So which is greater than 100 meters, so it will stop somewhere here. This distance will be equal to, we call it x2, and 128.5 meters. It means it will be still moving at point 2. This is what we just checked. So at point 2 it will be still moving, so velocity v2 is not equal to 0. Okay, we know it. Now we can find time. After how many seconds it will be at point 2. So we can use this equation: x1 equal to initial velocity times time minus 1 over 2 at square. Actually here we have negative sign. I'm using it directly here, so we should be careful. So we can use this equation and find time, or we have alternative way, but we need to use two equations. Let me use that one. So final velocity at point 2, or velocity at point 2, equal to initial velocity at point 1 minus 2a x1. By using this equation we can find velocity at point 2, so which is square root v1 30 square minus 2 times 3.5 times 100. So this negative sign is coming from accelerations, don't confuse it. So from here v2 will be equal to, further is just pure calculation, square root 900 minus 2 times 3.5 times 100, approximately equal to 14.14 meter per second. We know that at point 2 it will be still moving, and this is its velocity at point 2. Now we can use velocity at point 2 equal to velocity at point 1 minus a times time. Why I prefer this equation instead of this one? Because here we have a quadratic equation, so I don't want to work with quadratic equation, but I'm sure you will get the same result, same answer. So from here 14.14 equal to 30 minus 3.5 times time. From here we can find time. So it's equal to approximately 4.53 seconds. After 4.53 seconds it will be at point 2, or it will move 100 meters. Next part B. What is the velocity of boat when it reaches the buoy? We already answered for this question, which is 14.14 meters per second.